Student, so far we have discussed two different aspects as far as corrosion control is concerned. Today we will discuss on your cathodic protection. Actually, this technique is used to protect a metallic structure or the surface of the metal by converting the metal or by making the metal behave like a cathode in an electrochemical cell. As we all of us know that if somehow an anode is made cathode, it will not suffer corrosion because corrosion always takes place at anode, and therefore this is an attempt how to convert your corroding anode into cathode so that it will remain protected. Basically, cathodic protection is two types. Number one is galvanic type, and number two is impressed current cathodic protection. And the main difference between these two is that in impressed current cathodic protection, it uses an external power source with an inert anode, while in case of galvanic cathodic protection, it uses the naturally occurring electrochemical potential difference of the metallic elements to provide the desired protection against corrosion. Now let us start with this one, galvanic cathodic protection. This is also known as sacrificial anodic protection, because here one anode will be sacrificed to save another, and therefore it is also known as sacrificial anodic protection. In this approach, what we do, the metallic structure to be protected is connected by a wire to a more anodic metal, so that corrosion takes place only on more anodic metal, keeping the parent structure protected. The more anodic metal is also known as sacrificial anode, as it protects the base metallic structure at the cost of self-destruction. The corroding sacrificial anode is replaced by another one once it is completely destructed. Most widely used metal as sacrificial anodic metals are aluminium, zinc, magnesium, and their alloy. This technique is in use including protection of buried pipelines, water tank, marine structure, and underground cables. This is all about your sacrificial anodic protection. Now, let us discuss about actually impressed current cathodic protection. In this approach, what we do, an impressed current is applied in the opposite direction to nullify the corrosion current, and by converting the corroding anode to cathode. The impressed current which is being applied is derived from a direct source like battery or rectifier with an insoluble anode. Sufficient DC current is being supplied to the insoluble anode, which is connected to a metallic structure which is to be protected. Now this technique is also used for protecting water tank, other transmission line tower, and water and oil pipelines. This technique is particularly important for large structure and where long-term protection is required. There are two figures here that is shown here. This is your sacrificial, that is galvanic cathodic protection type, you see, and here it is impressed current. Here the power is supplied externally, but it is not like that. This is all about today's lecture. This is how actually we can control corrosion by cathodic protection. Please go through the video. If there is any doubt or confusion, get it noted, which will